In this video, let's solve part A of question 6. In this question, we have a continuous random variable x whose probability density function f is defined by f of x equal to 1 over 2a when x is greater than or equal to a and less than or equal to 3a, and 0 otherwise, where a is a positive real number. In part A, we want to state the expectation of x in terms of a. So, by definition, the expectation of x is equal to the integral from negative infinity to positive infinity of f of x times x dx. Okay. So we can decompose this integral into three parts. The first part is the integral from negative infinity to a of x times f of x dx, plus the second integral, which is the integral from a to 3a of x f of x dx, and then add the last integral, which is the integral from 3a to positive infinity of x times f of x dx. Okay. But if we recall our definition of the f of the probability density function f, we find that the first integral and the last integral are 0 because f is 0 in this interval. So this is because f of x is 0 when x is greater than negative infinity and less than or equal to a, and also when x is greater than or equal to 3a and less than positive infinity. So the first and the last integral are 0. Okay, so it is equal to the integral, the expectation of x is equal to the integral from a to 3a of x times f of x dx. But in this interval, the function f is just a constant 1 over 2a. So it is equal to the integral from a to 3a of x times 1 over 2a dx, taking out the constant and then calculating the integral gives us that it is equal to 1 over 2x squared with limits from a to 3a. Okay, so it is equal to 1 over 4a times 3a squared minus a squared, which is a times a squared. So it is 1 over 4 times 8a squared, which is equal to 2a. And so this is the answer for part A of question 6.